In this lesson, we are going to look at probability in society. This season, Haley made 44 out of 50 basketball shots that she attempted. What is the probability that Haley will make the next shot? Well, we know she's made 44 out of 50, and if we wanted to change that to a percent, it would equal 88%. So we say that her probability of making the next shot is 88%. Is this likely or unlikely? Well, because it's closer to 100%, it's more likely that she's actually going to make her shot. She's made 44 out of 50, so that means she's only missed 6. So she's more likely to make the shot than to miss the shot. Is it possible that Haley has missed 2 shots in a row this season? Well, if she's made 44, she's missed 6, so it is possible that she has missed 2 shots in a row, but is it likely? Probably not. If she's only missed 6, the chances that she missed 2 in a row are fairly small. What might increase Haley's chance of making the shot? Think of some things that might help. Well, maybe she practices a little bit more. Depending upon what types of shots she's doing, maybe if she actually gets closer to the net, she'll make the shot better. Or maybe she needs to be further from the net. Depends on what kind of a basketball player she is. What might decrease her chance of making the shot? Well, maybe she's not feeling very well that day. Maybe she's injured. Maybe they're playing a really good team and they have a really good defense. And so she's unable to get a good shot off. So there's lots of different reasons for what might increase or decrease her chances of making the shot. Probability refers to the likelihood that an event will occur. By collecting and analyzing data, predictions can be made about the likelihood that a certain event will occur. For example, meteorologists study past weather data to make predictions about future weather conditions. A 40% probability of snow means that under similar conditions in the past, it snowed 40% of the time, or 4 times out of 10. So a probability of 40% can be expressed as 4 out of 10, a fraction of 4 over 10, or a decimal as 0.4. So probability can be expressed in a variety of ways. Experimental probability is the probability of an event calculated from experimental results. So you're collecting data to determine the probability. Whereas theoretical probability is the number of favorable outcomes written as a fraction of the total number of possible outcomes. So in theory, what should happen? If we think about tossing a coin and you get heads or tails, in theory, you should have a 50% chance of tossing a head and a 50% chance of tossing a tail. However, if you were to toss a coin 5 times, you know you might get heads 5 times. So that would be experimental probability for that particular result. But in theory, it would be 1 out of 2. So which is the following here? The weather forecast says there is a 60% chance of showers. Is that experimental or theoretical? Well, just as we learned in a previous slide, the weather is forecast based on past data, what has happened in the past, so therefore this would be experimental probability. They've just collected data over time. So what about, there's a 5 out of 26 chance that a randomly chosen letter is a vowel. That would be theoretical. We know there are 26 letters in the alphabet, and we know that there are 5 vowels if we don't count Y. So in theory, your probability of selecting a vowel would be 5 out of 26. So it's theoretical probability. There is a 1 in 4 chance of drawing a heart from a deck of cards. Well, if you know what's in a deck of cards, there are 4 suits, and there are the same number of cards in each suit. Therefore, it is true that 1 of every 4 cards in a deck is going to be a heart. So that is theoretical probability. Tara won on 4 of 6 lottery tickets, so she is going to buy another. This would be experimental probability. She's bought 6 and she happened to win 4 times. We know this isn't always going to happen. You could buy 100 lottery tickets before you ever win. So the fact that she won on 4 of 6, she's on a lucky streak right now, but it is experimental probability. When you flip a coin, there's a 0.5 probability that the coin will land heads up. Despite this probability, you may feel strongly that the coin will land tails up. In this case, you have made a subjective judgment. These are not based on either theoretical or experimental probabilities, but rather on a hunch or a feeling. You often see this in sports. Maybe you've played on a team where when you go to do the coin toss at the start to see who's going to be home and who's going to be away, maybe your team always says you're always going to choose heads or you're always going to choose tails. Well, this is based on subjective judgment because in reality, you have a 50% chance of it being heads or tails. But it's your gut feeling that tells you it's going to be one or the other. So we want to explain how each decision is based on theoretical, experimental, or subjective judgment, or a combination of them. It is Aiden's experience that 4 out of 5 times the prize in the cereal box is found at the bottom of the box. So Aiden opens the bottom of the cereal box to find his prize. This would be based on experimental probability. Because in his experience, 4 out of the 5 times it was at the bottom. So therefore, he just goes to the bottom of the box. That's based on experimental probability. Suppose Aiden found the prize at the bottom only 2 out of 5 times. How would this change how he looks for the prize in the future? Well, now it's less at the bottom and more at the top. So again, it could still be experimental probability, but he's probably going to look from the top. Because it is fairly close to half, it might be a subjective judgment. Maybe his gut is telling him this time it's going to be at the bottom, or this time it's going to be at the top. It's a little more evenly split there, so he may have to use some subjective judgment. 2 friends are rolling a die. Out of 8 rolls made, a 4 came up 7 times. Austin predicts the next roll will likely not be a 4, since each number has an equal chance of being rolled. Maria decides the die is unfair, since 7 out of 8 rolls revealed a 4. Well, Austin is actually using theoretical probability. He knows that each number has an equal chance of being rolled. That's the theoretical probability. Now, when he says it will not likely be a 4, that could be a little bit of subjective judgment. The 4s come up so often, he knows in theory that shouldn't happen, so in his gut, the next one's not going to be a 4. Maria's deciding the die is unfair, since 7 out of 8 revealed a 4. So she's looking at it from an experimental probability aspect. 7 times you got a 4. Then again, she's making a little bit of a judgment that the die must be unfair, because that shouldn't happen. In past baseball games, Alice has made 2 hits for every 5 times she is up to bat. So in the next game, suppose Alice goes up to bat 5 times. What is the probability she will get a hit? Well, she has, every time she goes up, she's got 2 hits out of 5. So the probability is about 40%. Now we're making some assumptions here. We're making the assumptions that the teams are at about the same caliber. That for every other team where she's gotten 2 hits every 5 times at bat, that this pitcher is going to be about the same caliber, or the defense is going to be about the same caliber. If any of those things change, her probability will likely change. But based on past, so based on the experimental probability, she has a 40% chance of getting a hit. Probabilities are based on assumptions. What assumptions do you make when you roll a die with 6 faces? Well, we're assuming that there's a different number on each side from 1 to 6. We're assuming it's not a weighted die. We're assuming you have an equal chance of rolling each of the numbers. So how would your chance of rolling a 5 change if your assumptions were not true? Well, what if there wasn't a 5 on the die? then your chance of rolling a 5 is 0. What if a 5 occurs on more than one side of the die? Well, then it might increase your chances of rolling a 5. What if it's a weighted die? So there's different things that would change if your assumptions were not true. John wants to learn how to snowboard, but does not want to take his lessons. His mother insists that John take lessons. John and his mother find an article that claims 68% of snowboarding injuries occur during beginner lessons. How can both John and his mother use this statistic to support their opinions? Well, maybe John's going to argue that, hey, look it, if I take beginner lessons, I've got a more likely chance of getting injured than if I don't take the lessons. 68% of people who take those lessons get injured. Why would I want to take them? Whereas his mother might use it as, look at how many people get injured in beginner lessons. Can you imagine how many people get injured if you don't take the lessons? Maybe everyone who doesn't take a lesson will be injured. So you should take it so that you have a less likely chance of being injured. So there's a couple of different ways that we can look at statistics, and that's what we want to get you to understand. When you see statistics in the media, newspapers, on TV, you have to really start thinking about this. Maybe a person also has to ask, how many people did they actually survey? Were they younger? Were they older? What age levels? What other kind of abilities did they have prior to this? You have to start questioning the statistics, because you can use statistics to argue two different sides to things. So it's becoming more aware of what you are actually reading and asking the good questions.